it's Dr. Know-It-All. I am back from Utah, obviously, except I got the shirt now. And I am with Dr. Scott Walter again because you say you have some interesting stuff about Optimus's feet that we did not notice before. So you can take it away.
Yeah,
what do you
so
got
let's
for
go
us?
ahead. And so I just need to go ahead and share my screen and do a little bit of setup here. I assume you can see this. So
yep.
A few hours ago, I just kind of put this thing out, tweeted this, and part of the reason I did it is that I have to do a shout out for Herbert, because for some reason he thinks I'm an interesting enough personality to interview next week. I don't know why.
I've done a number of times here, so I think so too.
And so I started putting together a presentation, and as I was going down and getting some stuff, suddenly I noticed, wait a minute, how did we miss this on the Investor Day? So it's kind of interesting, and well, I'll just read it out loud. Steve, Optimus, Astrobot, robot coming alive. We can rebuild him better, stronger, faster. Now, for those of you who are our generation, you remember this television series called The $6 Million Man, where an astronaut gets into a really horrible accident, kind of like RoboCop. It gets rebuilt,
right?
And the refrain, the phrase that came out of it was better, stronger, faster.
Right.
And if you look at what's going on in this image right here, there is a patient on the table and he's being rebuilt. So Steve Optimus that you see there, who I'm calling, is a little bit different than the other two. There's a difference between them. And that's the thing. And that's like the wait is like, I noticed something, that there is an improvement in Optimus that we're not aware of. Right. So let's go down. Let's see if we, so here's kind of a close-up, right? And I'm going to go to this image here, and let me go back. You notice the difference between the robots that were actually walking around and carrying everything,
right,
and what we have right there.
Yeah, the feet are quite different looking, it looks like, although the angle is different. But
yeah, we'll see it a little bit in the angle, but there's our side-by-side comparison.
Yeah, that's crazy.
Yeah, so if you look over here, you'll notice they're very, very flat.
Right.
And here, you notice it seems like, wow, it's got some kind of arches now, and also maybe some different foot pads and everything else. There's some interesting things that I'll be zooming in on and kind of wondering about as we go along here.
Including those 6 little holes there that are...
Yes. And I'm not sure that it's necessarily for attaching this foot onto the ankle.
Right.
Could be something else. We'll get a slightly better view of that. And there's like a couple other little details that will be coming along here. So, I mean, again, the robot is walking, and they are choosing to have the walking robots using the original feet.
Right.
Which are really, the most basic design. We see him walking on over here, and then finally coming on here and here. Right. The first thing I want to ask you, another thing that's different.
Like 2 slides to where he's making that pivot motion, because very, very awkward looking.
Yeah, that pivot motion was horrible.
Yeah.
The way he slides around and everything, and the way the feet are shuffling. It's just kind of an unnatural walk.
Can you go back? One more.
Go back?
Yeah, go back to that. Where is that?
Right there.
Right there.
I mean, look at that. It's like, whoa, what's going on here?
This would be the way you would have to walk if your feet were in you know what? If you had ski boots on, if you imagine the way you would have to turn around, because I just got back from skiing, you would have to do that weird thing with your knees because you can't move your ankles. So, so that's the problem, right?
They're kind of locked in there.
Right.
The other thing to just notice is right now is what is the operation that's being performed right now?
Right. It looks like he's putting his leg thingy on, which is also, I think, different than
well, I think that's the patella, or what we might call the kneecap.
Right. Oh, yeah, I guess that is.
And you know what?
Yeah.
That's in the design of Optimus, but I've never actually seen it. If you look at this Optimus and that one, the others, we'll see they don't have kneecaps.
Right. And they don't have shin protectors either. This has got...
I think they do. Yeah, it's hard to tell. I think they may have something like this, but when it comes to these kind of kneecaps, what does that mean, John? When you start putting coverings like this on?
It means you're kind of getting close to being done because you're putting on his...
Yeah. Your design is kind of starting to get to where you want it to be. Right. So you don't do this at the beginning, you do this at the end. So that's also another indicator right there. So we can see it again a little bit closer where they get one of the kneecaps kind of on here already. We get an idea what it looks like. I've been looking really closely to see if I can see any other differences between the arms and the torso and everything. I haven't noticed anything. The main thing is here, is on the feet. And there is some significance to that because that's going to improve the gait and the walking and everything, which right now is, I think, is the one thing that sort of limits them from really deploying it in a couple applications on the shop floor, is it might just be too slow because it's too cautious walking.
Right.
And so they might be able to speed that up a little bit. So here's another close-up of the foot and those holes.
Oh, it's got a Tesla T on the bottom there. That's cool.
Yeah. Oh, yeah. You did. Oh, my goodness. What, let me get back there. Yeah. So yeah, that's there's awesome. The T right there. There's definitely a Tesla T.
Right.
And yeah, this whole pattern is rather interesting. And I'm wondering if there's something else. You know, is it a way for fasteners? But, you know, why are you only having fasteners down here? I guess you don't necessarily need them up there because this is where you'd be connecting it possibly to the ankle.
But also it's very odd because it looks like there's two something.
Yeah, it's like 6 holes in there. That's a really weird pattern. What's behind there does not look like a fastener to me.
Right.
I could be wrong. I don't know if it's a sensor or something else. Some sort of pressure sensor. Who knows?
Right.
And again, I think it was just kind of looking to see how the knees are. I mean, you can see that they definitely don't have any coverings on the knees.
Yeah.
So they're getting ready to do that. Now, here we can see, this is a video that's originally released in the fall, I think in November, December, and re-released in January.
Huge. Those feet were huge.
And if you look at these feet, they didn't even look like the ones that are there. So I think this is somewhere between that and the other, because they're doing something a little bit different down here on the ankle.
Right.
That we see here. And I've always wondered, why are these wires here? What are they doing there if there are no actuators actually in there? Because we know there's no actuators. Right. And here's a close-up on that. So so Gennady is going in and doing a lot of manipulation of that. And I'm just wondering, all right, what's this about? Because that looks like, okay, perhaps it could just be for some sort of sensors that are in there.
Right.
But it also looks thick enough you could carry a slight current through there. I don't know, but I don't think it's actuated.
Yeah. Well, there would be. How do the feet rotate though? Currently,
well, see this. You see this right here. You see that there is one of the axes of rotation. So it's an axis this way,
right? But that can be controlled through the ankle, and so
that's controlled by these here.
Right.
And the thing about these is there are no encoders anywhere here. These are just follower joints, and you have no measurement there. So the measurement is inferred by the displacement of the piston.
Right. Unless there is a sensor that's giving it.
You might want some sort of sensor to really confirm that it is where you think it is. There is a sensor up in the servo drive to let you know how long it's extended. And from that, like I say, you infer, is this what it must mean? And you might be getting a little bit of force feedback as you try to change it in one direction or another. But it's possible that this is down here to get some additional information. And there's a reason why. I mean, they kind of allude to this need for state information to be able to do the controlling. So I suspect that's what it is. I don't think there's any measurements going on here at these joints, but there may be something down here where the impact is happening.
Right.
So that's just a guess. Now, this is the other thing. Everything's been hiding in plain sight. This goes all the way back to AI. When they showed the walking motion.
Yeah.
They did a zoom up there. It's like, look at that, the same shoes. Now, I'm not sure if these are air soles in here. I mean, it almost looks like it. I don't know how much flexibility is there. It's kind of misleading from these things because it looks like it's metallic and probably very, very stiff. But I would think you would want something a little bit flexible. And there are a couple of reasons why I think you want to do that.
And just to set the record straight here, this is a computer graphics rendering here. This is
a computer graphics rendering. Now,
because there was a
very clear
thing that blew up about whether it was real or not. This is fake.
Yes. You have to listen to this very closely on what Milan is saying when he talks about this. So this is the simulator that they had. So they were going through a simulator with their control system and trying to teach the neural network how to walk. And so obviously that's a very long process for them to go through the feedback to get it there. So the first steps that were kind of successfully working were in April. And we saw in that progression how it was not so good. And then it improved and improved and improved. And finally, they were getting the toe off in September 22.
Right.
And at first I thought, wait a minute, you're getting the toe off. Does that mean the Optimus you have is doing it? Because at that time, Optimus couldn't really walk yet. The new one, the old one could. So they get the what's in the simulator.
Crazy when I think about this. This is only 11 months ago that they started this process.
Yes. So they they have the toe off in the simulator, which means I don't think they have it in reality yet, or they may. At least they haven't shown it. Because when we look at the Investor Day video, that shuffling was not toe off. That was plop, plop, plop going on like that. So they may not have it fully working in reality, or maybe they do, because they probably know you can only get the toe off with this sort of foot design. It's not going to work with the original flat foot that they had. No way. So that's kind of my suspicion. And you know, if we look at this, so here's the video from there. If we remember, everything is kind of going along. I'll speed it up a little bit, and we'll look at that walking motion. And you see that's clump. Well, I mean, none of that looks like a toe off to me. And the idea is that you have like a heel toe kind of motion.
No, that's completely flat steps.
That's completely flat. So they haven't done anything, but they probably need something like this. And I'm almost wondering, you see right there where the balls of the feet are, you get that little concave thing. I'm just wondering if they're going to have some sort of flexibility there to help out. But in the simulation, it looks like the foot remains flat. They don't actually have any flexion going on there at all.
It is a really interesting factor in that, you know, with us humans, we have the ball of our foot and then our toes. And so we're able to toe off. But this does look very rigid.
Yes, right there. I was just kind of wondering, would they have something? Because look at that contour there. It's almost suggestive of something like that.
Right.
I don't think they are. I think they just said, "Hey, this looks cool," so we'll kind of round it off a little bit, a little bit of a design, and then put the logo.
And obviously, some sort of no skid grip on there. But
So this is again is like showing the video of the evolution of the walking that should be going on here. And if we watch what's going on there, we see that kind of really floppy kind of motion on the feet, just plodding along. And then the improvement where you're going to get the heel strike and then coming up on the toe and the need to do that. Now, in this case, Milan talks about the improvement, but he doesn't really talk about the reason behind the improvement. But one of the other engineers, Felix, kind of goes into it and alludes why you want to do it and heading in a particular direction. And a lot of it has to do with, well, first of all, this is an image we're just showing this is where we're heading. So, I mean, they've already had this design around for a while. They've already had the coverings for the knees kind of around. They're finally getting around to implementing that.
But it is really interesting that they, in their renderings, they were always looking at that foot design.
Yes. Now, I'm not sure if you can hear what he's saying here. Are you able to hear what he's saying?
No, I can't hear what he's saying.
Oh, it's too bad the playback. So somehow it lost the volume on what's going on here. But if you get into the video, they do talk about, first the locomotion planning and the desired path that you have and try to set it up in the reference trajectories. And
just for people who don't know, this was not from Investor Day. This was from AI Day.
Right.
So it's very last day of September 30th of 22.
Yes. And then they start to show the trajectory here. Now, the one thing he points out in this, and I'm sorry the volume isn't coming through, is he does mention the need for the toe off and heel strike. And the reason you do it is it changes the motion of the knee for energy efficiency.
Right.
So that's what they want to do. And this is the type of foot you're going to need to do that. So that means Optimus will stand up straighter, will use less energy to be able to do the walking. So that's a reason to go ahead and do it.
And also, he specifically is showing right there at the end the turning path where you can yaw the foot. Because right now you can't do that.
A little bit, I'm not sure that they're yawing the foot. I think what they're doing is they're getting the yaw from the hip. And when you're doing a slight turn like that, it's okay. When you're trying to do a full pivot, that's when you get something that looks awful. So it's probably a little bit of the hip flexion that's going in there to be able to lean into it.
Can you actually wind it back just a little bit to show the beginning of that turn?
Yeah, let's see if we can. So right in around there.
Yeah, right around
because they don't have the yaw capability in the foot. And if they do, this is what I think, if they do, it would be like a compliant joint. So I've kind of wondered if down where there it is, whether they have something that will allow it to move a little bit, even if it's not an active joint.
Right. I
would think that's a good idea. And Gary kind of agrees with me that you need something like that, or pretty much you're going to get the ACL tear on the knee joint because you're just going to put too much stress in there, or you have to take it around through the hip. So it would make sense to be able to do that, even in a slight curve like this.
Yeah. So
that would be my thoughts, that they may be doing something like that. But I think there's something else going on there with those wires.
Yeah, you're right. I don't think it is. It doesn't look like there's any yaw. It looks like the yaw is.
There's no capability for active yaw. That's for sure.
Yeah.
There could be the yaw just as a result of a reaction torque that you're going to be getting by trying to go around there. That you want to
there was, if you go back to the big giant foot though, that the kind of in between one, that clearly
this
right, yeah, right there. Whoop, whoop, whoop.
Oh, that one right there.
No. Go back to the one that the guy that forward, that one right there. So if you go to the close up of that, you can definitely see, see that the foot there is definitely a pivotable area. There, it's clearly not welded in.
Yeah, it looks like it. Yes, it really looks like it. So
what if it was just passive? Let's say that there was a spring that was holding it.
That's what I think.
And it would just, if you gave it some force, it would just kind of it would yaw just a little bit. Yeah, like you were saying.
Yeah, because there's no reason to make this circular. Right. You could make it square if the whole idea is that you don't want it to move. If you want it to be able to move, you make it circular. But if you want to make sure, you can't do that. So I do think there is something in there. And so that might be part of the key of this thing, is to measure exactly what the torque is that's being felt at the foot. Plus maybe a little on some sensors on the foot plate to get an idea of where the pressure is being applied, where the reaction is coming from. So they may have a little bit of that, and there's kind of, I think, a good reason why. And again, if we go to these videos, it's really worth going back to AI Day 2 and looking at them again, to see how good the presentations are, how well prepared they are, and the handoffs from one to another. Right. And so the whole idea is that no one is working in a bubble where they're not aware of what anyone else is doing. It's constantly like, oh, you can do this, but in order to really solve the problem, we now have to do this. Now my friend's going to come in and he's going to talk about the rest. And so it was constantly this idea that we're well aware of what everyone's problems are, which is how they work. Right. Is they don't like being, so focused on a problem, they forget about how you have to integrate it with everything else. And that's what kind of impressed me about it. And that's the point it was constantly coming across. This is a really good team that works together. Right. So then the handoff is to a note from Felix, and he goes into talking about, how things work in kind of the real world in the simplified model. And the idea is that you have kind of this ideal model of your robot and your ideal world model, and it walks really well in there. You have absolutely no problem with it, right? So kind of like what they're showing in the simulator. Right. And then you take it out in reality, and reality shows you something different, because your bot model is not even correct, because your bot model has all kinds of vibrations and inertias and masses and just other things that are going on around it. In your real world, of course, is very complex compared to what you would have in a virtual world. Right. And so when the ideal world bumps up into reality, the behavior is that your dynamic model becomes unstable and it falls down. So if you don't understand what the real world is going to be throwing at you, you don't know how to model it to be able to react to that. So that, they're constantly having that problem of being able to do the reaction. And so he says, what you do with the locomotion model is like, this is my planned trajectory. I want to go along this trajectory. Now tell me how much I'm deviating from it. And as I start to deviate it, your control system is going to try to get you back to where you want to be. But in order to do that, you need to have something they call state estimation. Right. You need to know the physical state of everything, what's going on. And he refers to that as like the vestibular system in our body, where we have our own sense of balance and everything and where it is, plus a little bit more, and the importance of being able to capture that data. And so they're getting information from all the encoders here, but there's one place I know they're not getting any information based on the encoders, and that's what's happening right down here where the feet are in contact with the world. Right. That's literally where, the rubber meets the road. And so you need to know what's going on down there. Right. And so, then they talk about that, once they get that state estimation, from the reality, now the motion control understands the real behavior and how to respond to it. And so you go from this bot falling over all the time to now this bot is able to take a little bit of a perturbation and deal with it pretty well. And I think they're discovering that, the state estimation model, we don't have enough data. We need some more data points right now. And it may be coming from sensors down the feet. That is my guess. And sort of the importance of those. Was that my last slide? I can't believe it. Wow. Wow.
It's a very impressive looking finish slide. So there you go.
Yeah. All right. So
but yeah, it is interesting though that from the get-go, the renders did have the foot with the arch on the top. So it's a really interesting. Can you go back and actually present like one of the slides that shows the side of Steve Optimus, his foot? Because it is a fascinating looking foot area. It looks more like a human foot because it's got like
it does.
But then it still has this very, very flat plate that it steps on.
Yeah.
So it seems like it would make more sense if you would just have it without the plate where it could sort of flex and touch, but then you would not have a lot of contact with the ground because it would only be 2 points as opposed to the whole.
Right. And I think the other thing is, it seems like they already had these ideas designed. It's just that they wanted to go ahead and maybe work some other issues through before going there to get a little bit more data. But it is rather interesting that
is there like a more sideways? Is there? I think there's a little bit more side-on view.
Let's see. We got one here.
Yeah, there we go. So you can see the left foot there. Yeah, I mean that is a really high. It's not.
That's a high arch. That's a very high arch.
Of the foot. Yeah.
Compared to this, I mean, this is like right flat on the floor.
That looks like a Ronald McDonald foot right there.
Yeah.
It's like a clown foot.
And then here you've got something. So it means Steve Optimus is a little bit taller, than the original one. So he's got slightly bigger feet.
That's true.
And I wonder why they didn't go with this right away, since it seems like in all the renderings it had already been considered.
Yeah, I mean, maybe it just ended up being too complicated to try to. Maybe the balance was difficult until they figured it out.
Oh, there was something else. Yeah, maybe they needed to get a little bit of data information before they did it. But then you can see that they're working through some other prototypes to get some information. But yeah, there it is. I mean, we can see that is substantial clearance from the floor.
Right. And I guess the reason why it's filled with nothing, with air, is just because of weight. It would be very expensive to, I mean, it would be heavy if that whole thing was aluminum.
Yeah. And the other thing I would say is that, you've got I'm thinking you need to have some sort of flexibility in your foot.
Yeah.
Because the idea is if you're coming down a flat surface, the only way you can keep really good contact with the surface is that you just have to either straight up or come down.
Yeah.
But if you start to do this toe up, suddenly all of your force is right at the very front. It just kind of goes from here to suddenly there without a transition.
Right.
I think you would want something arched that can flex a little bit to make sure you maintain a little bit more contact.
Go back to the side-on view of the real one on the table, because I have a thought about this. If we go back.
Okay, we go up. This one, not quite.
It's more side-on from that.
I think it was. I'm backing up here. Okay, let's go all the way to the. Okay, there we go.
That's fine. Okay, I don't know, and I'm trying to look at the foot itself, but I was thinking if the bottom plate and the top foot were not welded, say, and there was a little bit of give, you would actually spring load that. So one of the things that humans do, our tendons spring load.
Yes.
So as you step, like the foot, for example, flattens, but then as you toe off, you get a little bit of a spring.
Exactly.
And so if there is some play between that bottom plate and that really high arch, you would get a little bit of flexion from that as you step on it, as you weight it, and then as you weight off of it, you're getting a little rebound or something that would help.
And how we're doing it is not obvious to me.
No.
Because I don't see anything that looks like it's flexible, like you're usually used to seeing with some of these carbon graphite prosthetics that are designed to do that, to actually spring load and then push off, and spring load and push off. And it's not obvious, but it seems to me that that's what you'd want to do.
Right.
And the fact that we don't see any direct evidence of that, everything is still very, very flat.
Yeah.
And here, it's hard to tell. Is there any sort of arch? It's a computer rendering, so you just don't know.
But that one looks like, that side view looks like there is a little bit more, that sort of blackish area between the two parts could potentially be something that's compliant, that can just wiggle.
Could be an air sole, simple as that,
Honestly, that's about it.
I mean, it looks like a pair of Nikes to me. There's a big air sole right in there. I kind of wonder
Optimus got some kick-ass kicks.
Yeah. The other thing is that maybe we're looking at it wrong. Maybe it's able to push down on here, and that slides forward and pushes back or something.
Yeah, that's kind of what I meant, was that it would actually it would. So
you get the plate is down on the ground, and then the foot is somehow sliding and pushing back, like, as opposed to actually bending. I don't know. They may have some wild ideas.
It is. They didn't really show the side of the foot completely clearly, so it's a little hard to tell. And it could also, we could be looking at another iteration of it that hasn't quite gotten there yet.
Yeah. And the question is, yeah, was it good enough to start walking for them to be able to produce this video? Maybe not, or maybe they're teasing us and saying, oh, this video was shot like 3 months ago.
Right.
And we're way past that point now.
Well, there is a sense in which they probably don't want to give away everything at this point, but
yes.
It is really interesting. I mean, when you just take this one part, just the foot, and you look at the number of iterations that they've done, but at the same time that they obviously had this in mind from the beginning, this was the thing. So yeah, fascinating. Anything else? So, and then we got the 6 little holes on the heels of each one, which again, who knows what that is? Maybe the way the plates are mounted, there's actual there's little, some sort of springy material there, and so the heel is the area.
Why they need access to it? I mean, what I'm wondering is, it's not to attach the tread onto here.
No,
and I'm assuming, is it that the tread is somehow affixed to the bottom plate and it's really hard to take off, but then we have to get the bottom plate mounted to the other, and so we need to have these holes to be able to put our screws in. I don't know. Maybe that's it, but they don't look like them to me.
No, and also it doesn't.
There's people out there that know. Please.
It honestly looks like power leads. Like you got a positive and minus, positive and negative terminals there, or something. I'm just saying it's odd. And you can't really see the right one nearly as well, or the left one nearly as well. So you can't tell if it repeats over there or not, but there's definitely still 6 over there.
Yeah, there is over here. There's
and you know what? Actually, I'm looking at this. I don't think they're clumped the same. They're not inverted from each other. They're actually identical. So if you look at the 2 up at the top,
can we see it here? We can't quite see it here. Yeah,
I think the one you were on was better, but it actually is really weird because see how it's not inverted. The 2 feet has the one at 11 and 12, and then at 2:30 and 3:30, and then 7 and 8. But it's the same.
That is weird.
It doesn't flip them. So
yeah, it's rather than being rotated, it looks like it's a translation between the two.
Yeah,
you'd expect there to be a mirror pattern.
That's really, really odd. You'd think that they would flip it.
No. I mean, maybe because of the components they want to put in there, they don't want to have to build 2 components.
Yeah.
2 components are the same.
So it probably indicates that there is something mechanical then that's a linkage that maybe. But still, I'm not sure what axis of symmetry they're kind of using along here. Right.
It does seem kind of weird. You would think you would have something coming more along here. Instead, it's rather weird the way they have it set up. And like you say, it's just offset over. But remember, the Optimus fingers are all the same length.
Right.
Because they don't want to have, too many skew numbers as far as how to build this thing. So it's probably the same thing. It's completely interchangeable, whatever that thing is. And you don't have to have a left and right version. So I think if you go through the whole thing, there's probably the only thing that's left and right is maybe this foot pad.
Right. Yeah, and everything else is identical. But even if you look at that, the placement of those holes is not the same between the 2 feet. So even that's different. Well, or no, it's it's translated, but then it's
translated. Yeah, but these dots here should not be over here. They should be
right.
Here.
They should be there. Exactly. And so
so that should be mirrored. It's not. So you've lost symmetry. You have translational symmetry, but you don't have rotational symmetry.
Which is really mind-blowing. Is someday when we find out what this is, we're going to be like, oh,
of course. Yeah, we completely missed it. Yeah. Well, we're going to be getting blasted in the comment sections with what it actually is. I'm sure
I don't know. I mean, if somebody knows what it is, let us know.
Yeah, put it in there. Then John will invite you on. Okay.
There you go. I just love how the socket wrench is right there. So it's indicating that somehow you're So, all right.
Yeah,
I think
believe it or not, that's all I have.
Yeah.
How long did we take?
Let me end the shared screen here. So stop sharing, continue. Yes. Oops. No, I don't want to share. No.
All right. I stopped.
To do that. Yeah. All right. So, so you have any final thoughts? That's really fascinating. And who would guess that looking at still frames of feet would be so fascinating? Do you have a foot fetish?
Yeah. Well, it's
an Optimus foot fetish.
I should have noticed it earlier. I was just kind of surprised. How did I not see this 2 weeks ago when it first came out and the differences? And then realizing that they've had this design for a while, but they haven't implemented it. And so it means that the walking gait is probably evolving pretty well right now. They're getting close to whatever the September 22nd simulation was showing, that maybe they could start to do it in reality. And I think I mentioned the other day when we did the comparison between the Shanghai speed video and the possibilities of where it could be used, that the only thing that's sort of keeping Optimus from being used in the factory is it probably just needs to be a little bit faster. Just a little bit.
Yeah. And yeah, so and obviously that would be something they're working on. And I think a lot of people are just to reiterate this again, that a lot of people are like, gee whiz, it doesn't walk as well as like, you know, some of these other bots and things out there. But Tesla's that's not the only thing they're working on. This isn't a demo of a robot walking. They're making it so it can do useful things. And walking is just a part of that. So it's all in parallel. You know, they're not just working on just the walking to make it walk really well.
Right. And if they need to deploy resources, they're deploying it in one particular area and saying, well, don't worry, we'll get to that a little bit later. So they're laser focused on one thing, and they say, oh, we seem to have that now. Now we're moving on over to here. And the fact they're moving into there tells me that they're getting pretty close. So I think they're at like version 0.9 right now. Which means they're pretty close to starting to scale it up, to start getting more Optimi produced, getting and doing more and more things. And of course, I could be completely wrong. They may already have like 200 or 300 of them already built. But
hey, Randy Kirk would believe that.
he would believe that. But I believe it's sort of proof that they're at the point that they can start scaling up. You don't want to scale up when you are still iterating so much in your design that it's going to keep on changing and changing and changing. But right now, it seems like they might be getting pretty close to say, all right, we can go ahead and start doing it. And any changes are going to be minor changes.
It's one of those things where if you compare it to like the 4680 batteries, the Cato Road pilot plant, they figured out a whole bunch of problems and got it working on this big of a scale. And now at Texas, they're trying to do it on, you know, order of magnitude or more bigger. And they're discovering all sorts of other problems, like just the fact that a little bit of dust actually eventually wears out.
Oh yeah, exactly. Yeah.
You know, so with
Optimus, something long enough. Yes.
Right. You want to get Optimus built out to a point where you're like, we think that this is an ideal situation to mass produce. Then, of course, you mass produce it and discover that there's a bunch of other stuff that you need to fix too. But, you know, it's all a process. So, and I love the fact that, as you mentioned, just the fact that the decap is going on means that they probably feel like they're getting pretty close. You know, that's more of an aesthetic protection sort of thing to make sure that nobody puts their finger in the joint and gets something. So,
it's partly that, and to make sure you're not exposing any components, to dust or to be snagged. Because they have a lot of wires that they're going to have to cover up, especially the wrist. I mean, that's my concern is you are seeing a lot of wires there. Right. But they're like, we're not worrying about that right now. We're just going to make sure it does everything correctly. And then they'll figure out exactly what the cabling package is going to look like.
Right. And then of course, probably some sort of covering over it to
Oh yeah, they'll clearly be covering. And the question is it just kind of a simple fabric covering? That might be all it is. And we're thinking, it's going to be some sort of hard plastic, something like that. Maybe the easiest thing is like, yep, it's just going to be fabric.
So there you go. It's really all you need is just something like that. That's a little bit of a harder fabric. Yeah. And plus the fact you could shape that into whatever shape you need it to be in.
Anything you want. Yeah. And it's easy to change out.
Yeah. Cool. All right. Well, thank you so much. And for people who are like in the know about robotics and stuff, and if you know what those holes are in the bottom of the feet, let us know. Or other things about that particular sort of foot shape. We should go back and look at Dennis Hong's stuff and see what he's done with UCLA and whether he maybe has done a prototype foot. If I'm remembering correctly, most of his feet were pretty flat, but it would be interesting to go back and look.
And they're actually wearing trainers now.
Yeah, right.
The Artemis is wearing trainers,
covering him
up. So he's covering up everything, so we can't see the details.
Right. So we don't even need to worry about trainers for this guy because he's got Nike Airs that he's just wearing.
Already built in. That's right.
Just built in.
Comes equipped. Yep.
There you go. All right. Thank you so much, Scott. I really appreciate the time that you've spent, and I hope everybody else does. So thank you so much, and we'll see you in the next one. Bye-bye.
Yep. Bye now.